Now we'll see one more important aspect of network layer. So in network layer, see the story. So you will be having application layer, transport layer followed by network layer, correct? So transport layer is going to give the data to network layer. Network layer is going to transfer the data to destination. You remember one thing. Somehow, source will find out the IP address of destination. We'll see how it finds. Let's say this is source, this is destination at this moment. So somehow this X is going to find out the destination address, and that source address and destination address will be given to the network layer. So network layer is going to send that data to exactly to the particular system where the IP address matches. For that it uses the routing tables, everything already we know, right? So apart from that, so I would like to tell you one thing. So finally using this address, IP address, whatever, so it is communicating with destination, right? I can say, so X and Y are going to communicate through network layer. That means the responsibility of the network layer is finally sending the data from here to here. Of course, for that it uses this internetwork, right? So that is also known as switching network. Through various routers, everything we are going to send. But I can say the very important functionality of network layer is giving end-to-end connectivity. That means, so your network layer starts here, that means takes the data here and it will forward it to end. Till that time it will work, right? So that's why, so I can say that network layers functionality is from source to destination, whereas data link layer's functionality is link to link. Okay, so remember one thing, that is the difference. Example, let's say that always the duty of the data link layer is simply like this. Someone will give you frame to data link layer, so simply it will try to send to another link. That's it. That is the functionality of data link layer. The difference between data link layer and network layer is network layers functionality is end to end. That is one thing you remember. Second thing, so now this network layer is going to give services to transport layer, right? So what kind of services it can give? Two kinds of services generally network layer can give. One is connection oriented service, second one connectionless service. So connectionless service means whatever the data which is given by transport layer, that will be taken by your network layer, let's say packets. Okay, so finally your network layer takes packets. In every packet there will be destination address. Okay, now these packets will be transferred independently because everyone has the address, right? So let's call them packet 1, packet 2, packet 3. According to the application level, packet 1, packet 2, packet 3 are similar or relevant. That means they are related, but for network layer they are all independent. Now all these packets are going to be transferred to the destination but independently. So your IP layer thinks that, otherwise network layer thinks that every packet is independent, so that it can have this kind of model. So we'll see what is this model. First of all, we'll see the idea. So how this network layer is going to send packets to destination, we'll see. Let's say this is a switching network. First of all the packets will come to, let's say, router A. Okay, now first of all, so your router is going to process P1. So P2 comma P3 will be buffered first of all. Okay, so whenever a router has excessive data, it will buffer it. Slowly it will process it. Now this router will see this P1, it will see the IP address, everything. It consult the routing table, everything is a separate story. Based on that, it will take the decision that it will send data to B. Okay, fine. So finally A realized that we have to send the data to P1. Now next it will process P2. By that time what can happen is, its routing table might be updated. You remember one thing, we are going to learn routing tables and routing algorithms generally. So routing algorithms, routing tables are dynamically updated. Example, today you have some idea about some connectivity. Next time after some seconds, so you might change your idea. So because of that, so what you realized is, so B has lot of traffic, that's why your routing table has been updated. The next hop for P2 is decided as C. After that, there is a chance that we can change our again idea and we can move our next hop to P3. That means though P1, P2, P3 are having same network address, first packet we can send to B, second packet we can send to P2, third packet we can send to P3. Depends on your routing algorithms. Okay, so what is the advantage of doing that? Maybe that router A thought that B is heavily loaded. That's why, so your network layer is responsible of maintaining the congestion, like decreasing the congestion. For that, it will take some strategies. Because of that strategies, let's say first packet is sent to B, second packet is to P2, then P3. In that way, maybe load balancing is going on. Okay. So slowly P1 will come here. So P2 will come here, P3 will come here. Now eventually they reach destination. But here one important thing you should realize that whenever each packet comes independently in different path, then anything can happen. So we cannot predict the delays. So out of order packets may come at destination. That means P3 might come first, after that P1, after that P2. So in this model, this is called packet switching. Finally, remember one thing, now currently internet almost 90% of the times, 90% of the networks in the internet uses packet switching. So it's such a phenomenal idea. So definitely, this is very flexible. We will be seeing one more model, virtual circuit switching. So we can compare them. So it's quite flexible, right? You are taking every packet independently and you are just pushing into the, this inter-network based on the load and everything, correct? So you will have lot of flexibility to understand where to send, right? Which one is empty line, which one is busy line, everything. So that effectively we can send the data. But the only thing is in this model, so data will be out of order. Sometimes, you lose the data. Of course, losing the data is quite obvious, sir. Why we sometimes we lose the data in this network level? In data link layer, we have seen why we lose the data, right? But in the network level also, if you see, you can lose some data. When I will tell you. Example, there is a router. So everyone realized that, not only this, so many routers realize that this router is doing very well. That means if we send the data through this router, then it will be very easy for us to send the data, so the data can be fastly transmitted. Everyone realize that and they are sending the data to this router. By that time, so what happens if it really that happens, then this router, everyone send the data, then it has to buffer it. If it doesn't buffer, then how data will be, retained. That's why this router is going to buffer all the packets, P1, P2, P3, but still packets are coming. So this router will have limited buffer. So this buffer is going to be, overflown. That's why whenever buffer overflow occurs, some of the packets will be discarded. So what I want to say is finally in this network layer, if you see devices and all, so if the model is connectionless service, so simply packets will be pushed into the network, I can say, then slowly they will come. But in this process, some of the packets you may lost, remember it. Okay, but that is not the responsibility of the network layer generally in the connectionless services. Okay, so simply your network layer's idea is like this. It says like this: you give me packets, I will push them, I will try to do my best, that's it, but I don't guarantee anything. So that is the idea about packet switching. And packets, using the packet switching, your network layer is going to implement a service called connectionless service. Now second service is connection oriented service, we can implement using virtual circuit switching. We'll see what is connection oriented service. In connection oriented service, we establish a connection and we fix the route rather than like this random routes, right? Here every packet is going independently, but in the next one, virtual circuit switching, all the packets are going to going to follow a particular route. How it will be decided, we will see. That is virtual circuit switching. Let's see. Now we'll see virtual circuit switching. In virtual circuit switching, so how this same communication takes place. So here, so in virtual circuit switching, so we are going to have a dedicated path for any connection. Okay, example, let me take one system B. So system B is having some frames or packets P1, P2, P3. Okay. So P1, P2, P3 are going to be transferred to, let's say, destination C. That is what the goal of B. So in packet switching, P1, P2, P3 went randomly, right? But here now, so in virtual circuit switching, so B is going to establish a circuit from from B to C. How it happens, we will see. For that, so every router will have this data structure. So incoming port, incoming virtual circuit identification number, outgoing port, and outgoing virtual circuit identification number. Using that, they are going to uniquely identify the path. We will see that. So before that, I would like to tell you one more thing. Here every router knows its ports, right? That's quite obvious. Every device will have ports. Let's assume that these W ports are 1, 2, 3, 4. Okay. So here X ports are, this is 1, this is 2, random numbers. For Y, port number 1, port number 2. Similarly for Z, port number 1, port number 2, port number 3. Now what is going to happen is, generally in packet switching, every packet will have destination address, right? Otherwise how can you send it? That's quite obvious, right? But in this virtual circuit switching, what we are going to do is, we are not going to use any source address, destination address. But of course, that equivalent one we are going to use here is virtual circuit identification number. So now every packet is going to get some virtual circuit identification number. So that will be unique for a connection. Example, whenever B wants to have a connection on that, so one particular number will be selected as a connection number. How B will decide is, randomly it generates some random number for that process. Okay. Usually what is the difference between virtual circuit identification number and destination address? Destination address is, in packet switching we use source address, destination address. They are usually IP addresses. In that way you can understand. But in virtual circuit switching, this is not this is not using IP addresses. It uses small numbers like virtual circuit identification numbers. Relatively, I can say that they are smaller in size, but IP addresses are generally large in size, because they have to uniquely identify all the computers of the world. That's why their length is little big. But here virtual circuit identification numbers, generally they will be local to a particular network. Okay. That's fine. Assume that, let's say this is your virtual circuit network where you are implementing virtual circuit. Then that virtual circuit identification number should be unique in this this scope itself. That's it. That is enough. So we will see now the broad idea, like how this virtual circuit switching will be implemented. Okay. Now let's begin with B. So sir, before that, how can they establish the connection and what is this entire scheme? I will tell you. Step number 1 in this process is, so whenever B wants to talk to that end system, B is going to establish a connection. First of all, it will try to establish the connection. So connection establishment phase is the first thing. Connection establishment. Second one, data transfer. Third one, connection closing. Okay, so they close the connection. Connection close the connection closing, I can say. So let's begin with connection establishment. How connection establishment takes place? So for that, remember one thing, while establishing the connection, B will talk to W, and W will talk to all its neighbors, X will talk to all the neighbors, and Z will talk to all the neighbors. And somehow they will identify the destination. First of all, how these routers will know the destination for that? So definitely in the connection establishment phase, we are going to use definitely destination addresses, IP addresses only. Okay. So that means B is going to talk to D first of all using the packet switching model. Okay. Assume that, let's say B is talking to W, W is talking to X in that way. Okay. But using dash, not virtual circuit identification numbers. At this moment we don't have. We talk to, now communication takes place like packet switching. Let me do packet switching and let me establish the connection. So using packet switching model, B and W will communicate, and B says that, my dear W, I want to talk to some destination. Do you have any bandwidth? Then W says yes. Then W will in fact talk to X, because to establish this entire path, W and X should communicate, right? Then W will X and communicates like this. My dear X, actually we have to send data to C, but do you have any bandwidth for that? If you have, then I will send. Then let's say WX says yes. Now here W also says yes. Just one of the possible idea. Then X will talk to Z. My dear X, my dear Z, actually we have to reach destination C, but can I use your resources? Is this path okay? Then let's say Z says yes, I have possibility. Then Z will talk to C, and Z knows that C is a destination. Why? Here in this process, B is going to give destination address of C to Z. So destination addresses are IP addresses. So by comparing the IP addresses, Z will realize that C is a destination and it will talk to C. My dear C, actually B wants to communicate to you, and every path is already almost ready. If you are okay, then we finish the path. In that way, Z and C will talk, and let's say CX says yes. Then finally, this entire path will be selected. In that way, so it takes a lot of time, I can say, correct? Finally, connection will be established. To establish the connection, remember one thing, the addresses they are going to use is IP addresses. Okay, so imagine like this. So using the IP addresses, we can, any two computers can communicate. So using that, they are going to communicate and they are going to establish the path. Now while establishing the path, so they are going to generate the virtual circuit identification numbers. Now I will tell you that process. So while B, talking to W, B says that if everything is okay, then B is going to give a number called something, any number like this, 27. B says that, my dear W, for all my connections, remember 27 is a number. 27 means my connection. So immediately, so W is going to see, this is W's data structure. What is the incoming port through which B is talking? 1, right? While connection establishment, this entire thing happens at connection establishment. So what is the port number? 27, okay, right, incoming, sorry, not port number, virtual correct VCI number. Now what is the outgoing port? Now W knows that outgoing port is 3, correct? Okay, because it wants to use this path. Now what is outgoing virtual circuit identification number? W doesn't know. We'll see what is that. So to understand that, so what is going to happen is W is going to send one control data, okay, through IP addresses only. So far only IP addresses, okay. Now W says to X, my dear X, I am sending one communication number, please note it. So here W is going to generate a VCI called 30. So slowly that 30 will come here. Whenever 30 comes here, then 30 will be noted here by X. X says that, oh, W's communication number is 30 and it came through which port? 1. Okay. Now what is outgoing port? 2. I have to send through 2. That is what I am thinking. Now what is the outgoing VCI? It will be empty initially, remember it. Now X is going to generate a different number called 40. Okay. Now X sends this data to Z. Now let me summarize. B sent a data packet with 27 as the data. Whenever 27 is received by W, W will fill here, okay, in its table. Now W generates a connection number called 30, that is going to be incoming for X. So X will generate a number 40, so that 40 will be filled by this one, his data structure. Okay, so here you see, this table is for this one. This table is for this one. We need another table for him, right? Z I am talking about. So Z is also going to have again 4 columns: incoming port and virtual connection identification, incoming VCI and outgoing port and out VCI. We'll see how he will fill. So Z is going to fill like this. So incoming port through which this data came 40, let's say here, right? Okay, 1. See, port number 1. So incoming VCI. So if he opens this data, he will see 40. So this entire communication takes place in the process of connection establishment. Now outgoing. So now this router is going to generate an address like some unique identification number. Let's call 70. So he will send 70, okay, to C. Now C's turn. C is going to decide everything. Now whenever C says yes, now I am ready to take the connection. So C is going to remember it. That means the connection, incoming connection is 70. We don't worry about C's data structure. C will receive 70. Now C is going to generate its connection number 80. C says that yes, I agree, my connection number is 80. Now whenever C generates 80, so that is going to be advertised to Z. So immediately what Z is going to do with that 80, I will tell you. So what was outgoing port? 3, right? Let me write here. So outgoing VCJ will be 80 now. Okay, from now onwards. So whenever data comes from incoming VCI 40, so it will be sent to outgoing line 3 with VCI 80, so that C can understand. So at this moment you can't understand completely. Once process is done, you can slowly understand. So now this Z is going to send information to X. What information? Simple information, that is its VCI, incoming VCI 40. So that 40 will be received by X. Where is X data? Here, right? So blindly X will fill that the data in outgoing VCI. Once it is done, X is going to send another data packet. Okay, so that contains incoming VCI. What is incoming VCI? 30. Okay, so keep 30 and it will send to what? W. So W's data is here. So W is going to write 30 here. That's it. Now 27 will be sent to data B. Then whenever 27 comes back, so B can understand that yes, connection has been established. This is the time B understands that connection has been established. Let me summarize. First of all, B generates a number 27 and asks for W. My dear W, really you want to open a connection with me? Please use a 27. So W says that wait, I will send 27 back. If I send 27 back, that means connection is established. So W now will talk to X. For that, W is going to generate a number called 30. So W sends 30 to X. Then X will write 30 in incoming and it generates another number called 40. Now 40 will be sent to this one. So 40 will be written here in incoming and Z will send another data to C about asking the permission of connection. These all numbers are related to connection asking. So now, this Z asks C, my dear C. So here, Z sends 70 and says that my dear C, so this is, my connection number. If you are okay with that, please say yes. Then C says yes and it will send 80. So 80 will be written here and its incoming VCI 40 will be written here and that incoming VCI 30 will be written here and incoming 27 will be sent to B. Then when B 27 comes back, so B understands that connection is established. Now how data will be transferred from now onwards, we'll see. So far for this communication they used IP addresses. Okay, whenever they want to send the data from left to right, anything. Now onwards, no addresses, simply this identification numbers. How you see? Example, let's say B has a packet number 1. How it will send packet number 1 we will see. Forget about all these numbers now. Already everyone remembers them. Now see the story. B sends P1 with what is the connection number? B knows that connection number is 27, right? It will send like this. Whether it will be received or not, we'll see. So slowly that packet comes to W. W will see only this identification number, no IP address. See, P1 is data, 27 is directly, address. So 27 will be used as address. So W will consult its table. It will index into 27. It may have lot of entries, but it will match like this. It will look into that incoming VCIs. So 27 will match. Whenever 27 matches, and definitely it understands. See, port number 1, yes, data came from port number 1 and VCI is 27. Then definitely, see, it understands that it is data from B. See, one more thing, you might have this doubt. Sir, what if A sends a packet like P1 maybe with 27 random number? Yeah, but port number will be 2, right? Then whenever such data comes, then 27 matches but port number will not match. So that means now this VCI and port combination is unique for one connection. So now A cannot use this connection. Now see, only B can use. So 27 1 matches immediately. So this is the outgoing port. That means exit. So outgoing port is 3. That means now see, your packet is going like this. Okay. Let me erase all these markers. Okay. Now you see the path how it is going. 3 and 30, right? Now remember one thing. So only packet will be sent. Okay. Now whenever it comes, now X turn. How X is going to do this thing, you see? So remember one thing. Your packet has VCI number 27, right? That will be replaced by this W. It will keep outgoing VCI. That is one important thing. Then only this connection will work. So P130 slowly will come to X. Now see, how X understand this one is, incoming port is 1, VCI number is 30, then it's matching. So this will be the exit 2, 40. So this packet will be sent through 2, port 2, and packet will be assigned now 40. That means throughout the path, so this virtual circuit identification number is going to be changed. Remember it. So eventually it will be received by this Z. Now this is Z's table. Now it will consult this table. Port number 1, yes, VCI 40. So it will index and it will understand that we have to send to 3, 80. So immediately through port number 3, blindly data will be transferred. See, now data is going to be transferred through a particular path. Now all the packets of that B definitely will follow the same path. Okay, this is virtual circuit switching. Now it will be received by C. Now see, data is P1 whatever it is and number is 80, correct? So whenever it reaches 80, then it understands that oh, this is from a particular B, correct? In that way communication takes place, right? Now we'll see the drawbacks of virtual circuit switching and the drawbacks of packet switching and the advantages of packet switching and advantages of virtual circuit switching. Otherwise, in one line we'll see the comparison between virtual circuit switching and packet switching. You understand everything. So one more thing, once connection is established, data is transferred, we have seen these two. Connection closing is very easy. In the same way, how you establish connection, in the same way we can cancel our connections, not a problem. Okay, so if you understand the idea, that is enough. So don't try to remember exact operation, not required. If you understand the rough idea, so in the GATE exam always they ask questions related to the rough idea rather than specific details. Okay, so because in GATE exam there are 10 subjects, no one can remember all the specific details about a particular topic. That's why understanding the concept is important. Somehow you understand the concept with some numbers. Let me ask one question. Are you remembering this 27 number while understanding the class? No, right? So you understand that it may be some 27 or 34, some number, right? So are you remembering that it is 27, it is 30, it is 40? For my class, so these are the numbers. But maybe other faculty can teach the same concept with other numbers, right? That's why that numbers are not important. In the same way, there are some more details like particular details are not really required. Try to understand that abstraction, that means high level idea, like how this functionality is happening. That's enough to solve any GATE question. Okay, so now we are going to see the advantages and disadvantages of this packet switching and virtual circuit switching. Okay, now let's compare packet switching and virtual circuit switching. So packet switching, also known as datagram subnet, that means the circuit or whatever the network is called datagram subnet. The reason in network layer the packet name is datagram, right? Now finally you are taking the packets which are datagrams and you are doing the packet switching. So that's why such kind of networks are called datagram subnets also. Remember one thing, 90% of the internet uses packet switching. That's why, so I can say that 90% of the networks whatever we have, they all follow data, they are all called datagram subnets. But there are some exceptions, that means there are some I can say networks which follow circuit switching. So where you can implement virtual circuit subnet, they are called virtual circuit subnets. Example, let's say, so the connections are given by your telecom services like BSNL, otherwise any telecom providers. Usually they have different networks. So they are usually called circuit switching networks. They will be having particular circuits. So whenever data comes to that circuits, networks, so a particular route will be taken. Packet switching is not possible over there. Okay, so that's why remember one thing, we have finally in the world there are two kinds of networks. 90% of the networks are supporting packet switching, also known as datagram subnets, and other subnets are called virtual circuit subnets. So already we have seen the two models, right? So we will see the comparison. Example, let's say you are using packet switching network, also known as datagram subnet. So circuit setup, do we need any circuit setup? No, not required. But circuit setup is required for virtual circuit subnet. Yes, required. Addressing, what kind of addressing we use in packet switching? Every packet should have destination address, source address, correct? So that's why, so we'll see why source address is required. At least the destination should know that from where the packet came in, right? That's why, so we use source IP address, destination IP address in every packet, especially in datagram subnet. But if you see, once connections are established, already I told you in virtual circuit subnet, so once connections are established, once path is decided, all the data will go with only that small virtual identification numbers, right? So that's why each packet has short VC number, virtual circuit number. Now we'll see routing. So each packet is router, each packet is I can say transferred by router here. Okay, each packet is transferred by router independently. Remember it. Yes, that's quite obvious, right? So in packet switching, every packet is independent. So routing will be done independently. Now if you see virtual circuit subnet, so then already we know that we have a particular path, only in that particular path data will be transferred. That's what I am saying here. Route is chosen when VC is set up and all packets follow it. And remember one thing, don't assume that every packet will go to a particular path. First of all, for a particular connection, one path will be established. Example, you can have like this. A, this is your network. This is, let's say, B and C. Okay. First time, let's say A is communicating with B. For that, it will establish the connection. For that, the path may be like this. After that, to talk to A to C, so A may use a different path. After that, again A wants to talk to B. At that time, it is opening a new connection. That new connection may go like this. So what I want to say is, finally, once connection is established between source and destination, then the path will be fixed. Okay. So next, effect of router failures. What if some router fails? Then in packet switching, not a problem, because if that router fails, we can send through alternative paths. That's why not a problem. But except while sending the packet, example, you sent a packet to a router. Okay, this is your router. Packet just came. Similarly, immediately this router got blast. Then your packet will be out of the game, right? So only in this kind of cases your packet will be lost. But what if you have a packet but you did not send? There are two routers. While sending, this router got failed, then we can send through this one, right? So alternative paths are there. So I can say that most of the times, router failures does not affect our communication here. Okay. Now, but here all the virtual communication will be gone, right? Example, you see, you have a virtual circuit. Okay. You established a virtual circuit like this between two nodes. What if one of the router did not work, doesn't work? Then if one of the router doesn't work, then you can't send, right? Entire path will be gone, because you are following a fixed path. On that one router is gone, everything is gone. Okay, that is a problem with effect of router failures. Now quality of service. So which one is better? In packet switching, there will be some uneven delays. Example, let's say you are sending audio data or video data to destination. This is source, this is destination. You are sending video data. Now here at destination, that application user is waiting for the data, but your packets will go randomly, right? So each packet will have independent delay. So here this receiver cannot receive the data in frequent intervals, right? We don't know when data comes. When we don't know when data comes, then there will be uneven delays. When there is an uneven delay, already I told you. Example, let's say your data is video or audio, there is an uneven delay. You feel jitteriness. Because of the jitteriness, quality of service is gone, right? So I can say that quality of service is very difficult here. We can't maintain the quality, especially in some applications. Okay, so definitely there will be some waiting. Now, but here in virtual circuit it is easy, because you have a connection, right? So that connection will be established only when there is a bandwidth with you. So you have particular connection, so definitely there will not be any problem. No waiting, nothing, correct? Everyone agrees on that connection. Only when they have resources, they are ready. So quality of service can be ensured, because every router, I can say, giving some bandwidth through some connection. So by giving that, so always we can use that bandwidth to that connection. So quality of service can be ensured. But congestion control. So what is congestion control? So here example, traffic problem in our cities. So whenever hundreds of people at a time come into the road, then what happens? Road will be congested, right? So all your city will be sometimes will feel congestion because of excessive amount of flow, correct? At the same time, in communication also, definitely you have excessive amount of data at a time may come into the paths, right? Then congestion will occur. So whenever congestion occurs, what to do? So in which area congestion is there and how to avoid, we'll see. So generally in datagram subnet, it is very difficult to maintain the avoid the congestion, otherwise control the congestion. Why? See, every packet is taking independent route. We don't know which packet goes in which way when it starts making the congestion, right? But in virtual circuit, everyone is following a systematic route, correct? Then we can easily control congestion. Example, let's say, so in some route there is no chance of having uneven, otherwise sudden I can say sudden congestion. Why? See, example, let's say A, B, C, everyone is agreed upon bandwidth, right? Everyone knows their limitation. Suddenly this router may not have lot of packets to process. What is congestion? Congestion is nothing but there is a router, that router is busy with hundreds of packets. That is impossible. Why? We'll ask. My dear B, you established a virtual circuit. That means what? Whenever you have resources, then only we establish, correct? If that is the case, when can I get sudden flood, right? It's not possible. And one more thing, see this one with analogy. Example, let's say, I want to talk to my students for some 15 minutes, okay? So I just tell like this, I give appointment to everyone. When I give apartment to everyone, then definitely I can serve everyone. If no one will feel congestion, no one will face a waiting time, everything, right? But if I don't give appointment, simply I tell my every student that now 9 o'clock to 10 o'clock today, anyone can come and talk to me. Then if hundreds of students comes to me and they want to talk to me, then congestion occurs. That's why in packet switching generally it happens, because every router says that any packet come to me, I serve. That is a model. But in virtual circuit, so router initially says whether it is possible or not, right? Because they are establishing the connection. So everyone is taking the appointment now. Every packet is taking an appointment. So easily we can control the congestion. So that's why it is easy. So these are all about datagram subnet and virtual circuit subnet. If you know these details, any gate question you can answer. Okay.